Hello everyone. In this video tutorial, I'm going to show you how you can create a simulation of an analog clock indeed, where you can set the time, the starting time, and then turn it on, and the clock works as a normal one. At any point, you can stop it and then set the clock again. To start, I have created an empty project. As the device, I have chosen CODESYS-SoftMotion Wind V3 X64, and as a result, here we have the SoftMotion General Access Pool. I have chosen CFC as the programming language, but you can use the other programming languages as well. So to start, I will right-click on the SoftMotion General Access Pool and select Add Device, and in the virtual drives, I will pick the SM_drive_virtual, and I will insert 3 axes, one for seconds, one for minutes, and one for hours. So we have 3 axes, and each one of those axes will be responsible for turning the corresponding watch or clock hand in it. Yeah, one for the seconds, the other one for the minutes, and the third one for the axis. The next thing to add is the image pool. In the image pool, I will add the file, an image file that I already have downloaded. So it is already in the CODESYS analog clock, and it's here. I will embed it into the project, and here we have it. Since we have it there, if I add a visualization to the project, I will be able to insert that image into the visualization. So basically, I will use that empty analog clock image without the hands, and then I will introduce the remaining parts. Let me show you how in the visualization we can include that. It just takes some time for my system to load the visualization. And here we go. So we have the visualization window already opened, and we have the visualization toolbox. Here we need to find out the image, which is here in the basic category. I drag and drop it here, and it already appears here. Yeah, I have the image pool. All right, so we have the base, let's say, for our clock over here already. The next thing that I need is the hands indeed for the seconds, minutes, and hours. For the hands, I will use the polyline. What I need is to make this in the form of simply a hand for the seconds, and I will put 3 of these with different size in it. One for seconds, one for minutes, and one for the hours. Okay, this is not a perfect one, but anyways, it will do our work, do what we want it to perform. That will be for the seconds. This one will be for the minutes. It's a bit shorter, and I'll try to make it wider. And the third one will be used for the hours. Again, it's shorter and a bit wider, just to differentiate them. You can work on the polylines to make them perfect in the form of perfect triangles, but that's not the purpose of what I want to show you in this video. I'm sure that you can work on it and make it perfect. Alright, so these will be the hands that we are going to use. You can also maybe color them, paint them in different colors to differentiate them easily. But again, I guess that is not necessary for this video. Now, the important thing is that we need to create the hour, minute, and second, basically the time, and then based on that, these hands that I have created will start to rotate. As I mentioned in the beginning, we have 3 axes created for them. If I start to look at the seconds axis, you can see the properties over here. And since we want to have this axis in the rotational form, we need to select the modulo for it. If you select finite, it will be in the form of a linear axis, but now it will be in the form of a rotating or rotational axis. And here we have the 360 degrees as the complete, let's say, amount that the axis could rotate. We need to do it for all the 3 axes that we have here. Alright, so we are kind of done with that. You can set the other properties as well, but for now I think we don't need them. This will be enough for now. Then we can go back to our PLC program. In the main PLC program that we have here, I would need to basically initially turn on or power on the 3 axes that we have. We should be able to find them in the SM3 basic, POUs, movement, and it is MC power. Let's see where it is. MC. Let me see if I can find it. Okay, let me look it for here. So it should be called MC power. All right, so it is here. We need to declare it an instance for the seconds. You can see that it is declared in the variables area over here. I need 3 of them indeed, so I will rename the second one as MC underline power min, declare it, and MC underline power hour, underline hour, and declare it. For each one, the main input is the axis. I would need to bring the input. I need 3 inputs indeed. We can first connect and then determine the axis. So for the first one, we need to associate it with the axis seconds. The second one with axis minutes. And the third one with axis hours. We also need to think about enabling setting the regulator on and starting the drive. Basically, what we can do here is to use a single input and give a name to it and connect all the 3 inputs of all the 3 axis power function block to that input. So in this way, by providing true value to a single variable, we will power on all the 3 axes. and we can call this, indeed we can declare it as a Boolean variable, and I'll call it as the start. It's a Boolean one, we declare it, and it appears here. Then we can go to the visualization. In the visualization, we can bring a switch, and as for the variable, we can associate it with the start variable that we just declared. We can also place a label here. Let me see where I can find the label. Yes. And here we have start written as well. So we know that this is for starting the timing procedure. Okay, so if I go back to the PLC underline PRG program, for now we can indeed start or power on the 3 virtual drives that we have. But as the next step, we would need to prepare the movement values for these 3. In order to provide the movement values for them, I'm going to use MC underline move absolute. From the SM3 basic library indeed. Let's declare the first one for the seconds. I need 2 more. The second one will be used for the minutes, and the third one will be used for the hours. For the axis, we need to refer to the same axis to keep the code that I have here clean. I will bring the inputs again, and I'll refer to the same axis as we had here. Okay, so now we are kind of set in terms of powering on the system and starting the movement. But what we need still to determine is when to execute the movement and the position for each one of these. For the second, we need to receive the position based on the time, for the minute as well, and for the hour hand as well. We need to receive all this. I will show you how to determine that, yeah. But before that, we can go back to the visualization. In the visualization, for each one of the hands that we have, we can say that we want to have the rotation for these based on the value that we get from the drives. So if this is the second, so it's the biggest one, I selected that, and then we have the movement, the absolute movement. As for the rotation, I'm going to select the axis seconds, and we have a property here which gives us the actual position of the axis. Let me just find it. It's in the form of a float, if I remember correctly. So it should be somewhere around here. It's not set position, F offset position, ramp check, no. Max, mark, last, actual. It should be something like actual position. Here we have the actual velocity, and we have the, okay, So it's a long real actual position. And this comes from the axis seconds. For the second one, we need to determine it for the axis minutes. And F actual position. And for the third one, we will do it for the axis hours and F actual position. So now if we give a specific value as the position input to each one of these, the corresponding hand over here will start to rotate and reach that position. The main part that remains here now is to determine the actual time and then derive the positions for each one of these axes. For that, we can start to insert an Rtc block. I'll keep it as Rtc0, and we have it here. For the enabling, I will connect it to the start. So as we turn on, let's say, the drives, we will set Rtc on as well. So it will be enabled. Then as for the preset date and time, instead of typing it directly over here, I'll bring it from the visualization. Let's call it as PDT set value. You can see that it's going to be declared as the date and time. We are fine with that. Now we need to specify some value for this. And for that, we can move to the visualization. And in the visualization, we will bring a corresponding indeed visualization element for that. I guess it's in the date and time controls. And here we have date and time picker. As for the variable, I will associate it with the variable that we just declared, yeah? PDT set value. All right. I can show you indeed what happens right at this moment. Let's go online after setting the simulation mode, and I will show you what happens when we pick a value over here as from the visualization, and then we will see it what happens in the actual code indeed. Let's wait for my system to log in. So now you will learn how to use this date and time picker in it, yeah, in the visualization. Okay, so by default, you can see that we have a specific value for the set value. So that's the default value that you would see. We need to enable the Rtc. You see that it is enabled, and now we can pick a value over here. So you can pick the date and also the time. We are not going to use the date, but anyways, you can pick it over here. As for the time, I'm going to use 14, 25, 56. And it should appear here. You see that it is 22, 30, 56. So this is the preset time, okay? We will set that, and after that our clock will start to continue. Now I will show you how we can use this Rtc together with the function block that we are going to create over here, because you know that Rtc will give us the time difference in it. from the point in which it is enabled and the preset date and time, it will give us the difference, and then we will use that difference in order to obtain the amount of the time that is passed, and out of that we will get the values for the seconds, minutes, and hours, and we will use them as the position input for these 3 blocks over here, and as a result our hands in the visualization will start to rotate. So I'm going to create a function block. That function block will receive the CDT as the input, so its input will be in the form of date and time, and it will give us 3 outputs in the form of hour, minute, and the second, and we will use them as the inputs to our functions. Okay, so I'm going to log out. I hope you know how to create the function block. You need to add an object in the form of POU, and it will be a function block. I'm going to call it DT to hour, minute, and second, DT to HMS. And again, you can use any programming language. I think I will use the CFC for that as well. Okay, so here we have it. As for the input variable, it will be in the form of date and time. So I'm going to copy and paste this here and then change this. So PDT, or let's call it DT input. So what do we have here? We will have the date and time. First, we need to convert what we have in the form of date and time. We need to take the time part, and then we will continue converting that in a way that we kind of get the desired output variables. Alright, so I just created the function block for converting the date and time that we have into the corresponding values of seconds, minutes, and hours. You can see how it looks like here. We have the input variable as DT input, and we have 3 output variables as second, minute, and the hour. You can see that initially we convert the date and time input into the time of the day, and then into the long integer we divide it by 1000 in order to get the whole time in seconds, and then we convert it using this simple way into the hour, minute, and second. I guess you can spend some time to get an idea how it is done if you didn't get it at the first sight. In a main program, I have inverted an instance of the D2 to HMS function that I just created. As the input, I provided this current DT from the Rtc block, and the outputs are in the form of second, minute, and hour. Now we need to convert these into the angles that we want to have for our axis. Yeah? For the second, it's kind of easy. We just multiply it with the value 6, because each second is kind of 6 degrees, and then we apply it as the position input to the MC underline move absolute for the second axis. Then for the minutes and the hours, we need to kind of do a simple math calculation. For the minutes, we get the seconds divided by 60 degrees, because now each second will kind of contribute, each second will be divided by 60 and contribute to the minutes, and then add it to the minute, and then multiply it by 6 degrees in order to obtain the value for the position. And finally, for the hour, the position comes from the division of the minute by 60 and adding it to the hour and multiplying by 30 degrees, because each hour will be equivalent to 30 degrees. And then we apply it as the position. For the velocity, acceleration, deceleration, and jerk, I have just set a fixed value of 50, but you can just play with that in order to get some smooth movement. Yeah. And one more thing here is that in order to have the command for executing the movements, I have used a blink function block. The blink function block is part of the util library, so you need to have it installed. If it's not installed by default, just add it to your project by using the add library. You will be able to find it in the application common, and it's here. So I just added that to my project. And with the blink, I will generate here pulses every 100 millisecond. In it, there will be a pulse which will tell my move absolute functions in order to move. On the other hand, for the visualization side, what you need to do is that initially I put these variables as the rotation, but you need to have it for the interior rotation, okay? So make sure that you do this for the second, and for the second, minute, and hour, I have just put them one under the other one, and I have changed the colors as well, so you will see them in action in it, okay? Now I think we are kind of ready to try it. At the first step, you would need to set the time. So let's say I want to set my clock to start from 15, 24 minutes, 10 seconds. If I press start, the clock will move to that value. It will show us hopefully it will show us the time, and then it will continue to show the time accordingly. So 15, 24, and 10, 15. Now the time has already started. Yeah, we should have now around 25 seconds. I'll move it here so we can see the values here as well. For the second, hour, and minute, the hour is 15 still. For the minute, we have 24 minutes. It's almost there. And for the second, we have 42 seconds, 44, 45. It's kind of following it. Yeah, there might be some minor, indeed, adjustments that would be required in terms of the velocity, acceleration, deceleration, and jerk inputs. And also for the blink, you might find some more proper, let's say, values in order to have a smooth movement and exact showing of the time. But I guess this is kind of working for our purpose. It should show us the correct time as we have the time increasing. I'm just not 100% sure about what we get with the hour here. So let me change the minutes to 50. 15, 50, and 10, and then okay, so our angle for the hour is not working properly. You see that it is still showing 3 while it should be much closer to the 4. But in terms of the minute and second, it's working fine. So let me fix that, and I will come back soon. Alright, so I just fixed the issue that we had. It was regarding the division that I had here. Division by 60 didn't give me the correct result that I was expecting, and that's kind of obvious, but I did that mistake. However, if you, instead of that, you multiply it with the 0.0166, which is basically 1/60, then you will get the smooth or correct values for the hour, minute, and the second. Over here you can see that now I started from a set value of 16:56:31, and it is running now for a couple of minutes. I can stop, change the value here. Instead of 16, let's go to 20 minutes, 20, on the hour is 20, we have 25 minutes and 46 seconds. Okay, and now we'll see whether it works correctly or not. So it moves to the initial value. Now you see that it is not, the hour hand doesn't point to the exact value of 8, but it has moved a little bit further. You can also have a look at the current values that you have for the axis over here as well. So we have it for the seconds, for the minutes, with the exact value shown here. So you see that for the minutes, every kind of second, the value is being updated. And also for the hours axis, it will be updated every minute. Every minute it will be incremented a little bit, and at the end we will have the final value. Alright, so I think that's all for this video. It is a bit longer than what I expected, but I hope you have learned something. First of all, you should have learned how to use the date and time picker in the visualization to indeed insert the desired time that you want to have, how to have these polylines, and then how to make them rotate. Also, regarding the virtual drives that we have here, you should have learned how to make them in the form of a rotational one, not a linear one. And also in terms of the programming, you should have learned how to use the MC underlying power, the MC absolute movement, the RTC, and how to convert the time that you get from RTC into the second, hour, and the minutes. So I hope you find the video useful. Please share the video, like it, and comment if you have any questions or comments. Thank you for watching, and see you in another video soon.